Hello guys, welcome back to Khaliltronics. In today's video we are in another method called hospital under limits. In calculus, actually the most important rule is called L'Hospital rule. This rule uses the derivatives to evaluate the limits which involve the indeterminate form, and then the indeterminate form are infinity 0 by 0 and comma infinity by infinity is all indeterminate, and then comma 1 for infinity or infinity for 0. So also this is indeterminate form. So we are trying to evaluate the limit which involve indeterminate form. Also in this article we are going to discuss the formula of L'Hospital rules along the example that we have brought right here. So basically it's very important, this method, and is very heavy to evaluate. So for the indeterminate form is as I said, is infinity over infinity or 0 by 0. So in our previous method, if you have 0 by 0, we can use a substitution method or conjugate. But in this method, we are going to apply hospital rule to evaluate the given limits. And then 1 over infinity or infinity by 0, they are all indeterminate form. So if you have such this, you have to use hospital rules. So actually hospital rules or method is generally method for evaluating indeterminate forms such as 0 by 0. So to evaluate the limit of the indeterminate form for the derivatives in calculus, so also hospital rule can be applied more than once, more than one time. You can apply 2 times, 3 times until you find a way to evaluate the given integral. So you can apply it 1 times if the question or the answer is not whole. You can apply again. So we are going to put the formula and then start solving the given problem. So the formula is given as if you have the function or limit. If you have the functions or limits, sorry. So if you have limits at what x goes towards c, let's say 3, f of x over what g of x. So if you have such this, and then you get indeterminate from 0 by 0 or infinity by infinity, or if you have 1 for infinity, yes, infinity, or if you have infinity for 0. So if you have such this, you can apply hospital rule. So if this exists, and let's say if limit x goes to c of this function given post f of x over g of x exists. So if this exists and what the denominator, let's see, if you differentiate derivatives of g of x, that's g prime of x, if it's not equal to 0, if you get the derivatives of the denominator not to be equal to 0, then you can say limits x goes towards c of what f of x over g of x is the same thing as limits x approaches to c f prime of x over what g prime of x. So the formula is given as if you have this, if the denominator of the given function, if you differentiate it and it's not equal to 0, then you can say the derivatives of the limit at x goes to at c f of x g of x is equal to limit at what let me change pen. At what x goes to what c, f prime of x over g prime of x. So what does that mean? So you have to just take, if you have to apply hospital rules, you have to just take the f of x that it is on the numerator, just differentiate it, find the derivatives of it, and then find the derivatives of the denominator and numerator as well, and then evaluate for the given limit. So this is the formula. As you see, this is the formula right here. This is the formula right here. So the formula is given if you have this. So you have to just find the derivatives of the up and then the down. That's the f of x and then the g of x. So it's very easy. I think no need to bother. So we are going to take, this is the formula. If you have this, you can find this and then substitute for the given limits, and then this x is meant to be equal to any number. So let's take question number 1 and solve. So the question number 1 is given from our list. To find what question number 1 is to just limit as x goes to 0 e to the x minus 1 all over what, this is question number 1, all over x. So let's solve it and see. So example 1. So So example 1, the question is very easy. We have to find what limit at x goes to what, let me change pen. Limit as what x goes to what 0. At x goes to 0, we have exponential of x minus 1, then all over what x. So you have to use hospital rules to evaluate the given limit, hospital rule. So actually if you substitute x to be equal to 0, so you are going to get 0 by 0. So if you have here 0, then minus 1 all over 0. So here 0, a to the 0 is just 1, 1 minus 1 all over 0, 1 minus 1 is 0 all over 0, which is what, indeterminate. So we have to apply hospital rules and see. So what it says, if you have the function as I said, if you have this function and then numerator and the denominator, so it's just to find derivatives of the numerator and then derivatives of the denominator. So here we have to say, we can say this f of x to be equal to what, e to the what, x minus 1, or g of x to be equal to what, x. So to find the derivatives of this, we can say f prime of x is equal to what, if you find the derivative of this, e to the x is just e to the x, derivatives of 1 is 0, then g prime of x is equal to what, derivative of x is just 1. So we can we can substitute. So we can say limit x goes to what, 0 e to the what, x minus 1 all over what, x is the same thing as limit what, x goes to 0 f of x over g of x prime, f prime of x over g prime of x. We have f prime of x as what, e to the what, x over g prime of x as 1. So you can also say equal to just what, e to the x. So we can substitute. You can say limit x goes to what, 0 of e to the x. We can say e to the x for e to the x at x equal to 0. We can substitute e to the 0. Alhamdulillah. E to the 0 is just what, 1. So the answer is 1. The answer for this question is 1. So we are going to take question number 2, which is the next question. So if you like, no need to write this all this. No need to write this. You can just take the function. You can see just differential of this that we have at the numerator and then differential of it. So the differential of this is just what, e to the x. Differential of the other term is 0 all over differential of x is 1. So e to the x over 1 is just e to x. So if you substitute, it become e to the 0. E to 0 is equal to 1. So if you like, you don't need to put all this, but it's just I show you the steps. So we're gonna take next question, and the next question might be very easy. So the next question is question 2 is what? Limit as what x approaches toward infinity of what? X squared by what? 2 power x. So it's infinity. We are trying to use L'Hospital rules, so we can say this to be equal to f of x, yeah, g of x. So g of x to be equal to what? You can say g of x to be equal to what? X squared g of x prime. So if I find derivatives of this is equal to what? 2x, and then we are to say here is f of x, here is f of x, here is f of x prime, f prime of x. So g of x to be equal to what? 2 power x, and g of x prime to be equal to what? So derivative of this is just to if you want to find this, you can say if you have a power x, so the derivative of this is equal to what? A power x again. You can say a power x and then ln of what? A. So if you have a power x, is just what? A power x and then multiply by ln a again. So here we can see, since we have this, we can see 2 power what? This is 2 power x then ln 2. So but no need to, if you like, you no need to say let f of x to be this. You can just find the derivatives of numerator and then denominator. So we can have derivatives of this. You have what? 2x as we got here, and then derivative of the denominator is what? 2x what? Ln what? 2. So since we are here, so and then our denominator is still, we have 2 raised power of what? X. So we can use hospital again. So we can say applying hospital, we can make this, we can collect this to be, we can say 2, we can make constant term separate apart, because here 2 is a constant and ln of 2 is a constant. So we can say 2 over ln 2 is a constant, then multiply by what? X all over what? 2 power x. So here we are to get we are to also do the hospital rules again. So here is a constant, we are to what? Find the derivatives of this. Derivatives of the numerator is 1, and then derivatives of this is still 2 power what? X then ln what? 2. So but remember, we have this, the derivatives of this is going to be equal to this, and then we have this, so you can say 2 all over what? Ln 2. So and then since we have was ln 2, we have 2 ln 2, we can say ln 2, sorry, we can see 2 times 1, we have 2 all over ln 2, we have ln 2 square, then times what? 2 power x. So we have 2 all over ln 2 what? Square, then multiply by 1 2 power what? X. So and then the limits, we are to get limit at what? X approaches toward infinity of what? 2 all over ln 2 all square, then multiply by 1 all over what? 2 power what? X. So here what you are trying to do is, like, if you say x to be equal to infinity, so if here is a constant term, no need to consider this. The whole year, let me change fan. The whole year is a constant term, so no need to focus on this side. The focus is on what the x. So as x goes toward infinity, so if you say we have, let's say, 1 by 2 power 100, so 2 power 100 is something 1 power let's say 2 exponential of 100. So 2 exponential of 1 divided by 2 exponential of 100 is almost closer to 0. So what if I say is equal to 1 all over 2 power infinity? So if you have, let's say, 1 divided by 2 power billions, so if you have, let's say, 1 divided by trillion, so it's approximately equal to 0, because there is no way you can divide it you can divide it 1 by, let's say, 2 trillion. How can you make it? So it's just approximately equal to what? 0. So since here, if you say 1 over what 2 power infinity is equal to what 0, so then 0 times this is going to be equal to 0. So let's compute it and see. So we can now say we have 2 all over what ln 2 square, then times 1 all over what 2 power what infinity. So 2 power infinity will have, which is equal to what 1 all over 2 ln what 2 square multiply by what 1 over infinity. 1 over 2 raised to the power of infinity is going to be equal to 0, as I say 1 divided by 2 power, let's say, billions. So this is going to be equal to what 0. So 0 multiplied by this, the answer is going to be equal to 0. So 0 times the whole this is going to be equal to what 0. So the answer for this question is what 0. So let's take the next questions. The next question is I think it's quite easy. That's question 3. The question 3 is given as to find what ln x approaches to 2 of what 1 all over 4 all over x square minus what 4 minus 1 all over x square minus what x minus what 2. So if we put 2, if you use substituting method to substitute x to be equal to 2, we will not arrive at the let's substitute and see. Here we have 4 all over 2 square is 4 minus what we have 4 also, then minus 1 all over x is what 2 minus 2. So here we have 4 by, here we have 4 by 4 is 0, so we have 0 here we have what 4 by 0 and then minus 1 all over 1 0. So it's not going to give us the definite answer, because it's indeterminate form. So we had to apply hospital rules to evaluate the given answer. So we have to differentiate. To differentiate, we have to clear the fraction. We can say here is different of 2 square. You can say x plus 2 all over what x plus 2, x minus 2, then minus all over x minus 2. So here we can take LCM. The LCM is going to be equal to x plus 2 all over, the other one is what x minus 2. So x, this into this we have 4 minus this into this remain x plus 2, we have what x plus 2. So here we can say 4 minus 2 minus x all over what x plus 2, the other one is x minus 2. Also we can say we have 2 minus what x all over what x plus 2, x plus 2. We can also say, since we know that this is different of 2 square, so we can say x square minus what 2 square, which is equal to what x2 minus x all over what x square minus what 4. As we already know that this, from here we got the LCMs, and this one is what is the difference of 2 squares, so we just take the difference of 2 square. So we can say ln of what x goes to what 2 of what 2 minus x all over what x square minus what 4. So if we substitute x to be equal to 2, we can have 2 minus 2 all over what x square. The x square is what is 4. We have 2 square is 4 minus 4, so here is 0 by 0, so it's not going to all, so we have to apply hospital rules to evaluate the given integral. So here we are just simplify it, we clear the fraction, so we have to what differentiate, find the derivative of numerator and denominator at the same time. So derivatives of this numerator is what minus what 1, and then derivatives of the denominator, derivative of x square is what 2x, derivative of what constant term is 0, so we have what minus 1 over x. So limit as what x goes to what 2 of 1 over what minus 1 over 2x, so which is what we are substitute x to be equal to 2, we have minus 1 over 2 by 2, which is what 1 over what 4, negative 1 over 4. So the next question is given, and it's also very easy. So the next question is very easy. We are to find what limit as what x goes to what 0 of what sine of what 3x all over what a sine of what 4x. So we are, if we substitute here, we are not going to have a what the appropriate one, so we have to apply hospital rules. So we can find derivatives of numerator. Derivatives of the numerator is what 3 cos what 3x, and then derivatives of the denominator is what 4 cos what 3x. So limits as what x goes to what 0, we have to substitute. So if we put x to be equal to 0, we will have what 3 cos what 3 times what 0 all over what 4 cos what 3 times this here is 4, I mean here it will be 4 power 0, so here is what 3 cos what 0 all over what 4 cos what 0. So cos 0 is equal to 1, so we have 3 by what 4, since cos 0 is equal to 1, so the answer is just 3 by 4. So the next question is limits as what x approaches to what 1 of what 5 raised power of x power 5x power 4 minus what 4x square minus 1 all over what 10 minus x minus what 9x cubed. So if we put x to be equal to 1, we are not going to have definite, so you know it's just hospital rules. We had to find hospital rules. We had to what limit as what x goes to c of what g of f of x g of x to be equal to what limit at x equal to what goes to c f prime of x over our g prime of x. So we have to just take derivatives of up and down. So derivative of off, we can say we have what derivatives of this, we have what 4 times 5, we have what 20 x square. Yeah, 4 times 5 is 20 x raised power of what 3, then minus 2 times 4 is 8x. Derivative of constant term is 0 all over. We have here derivatives of this is what 0, derivatives of this is minus 1, derivatives of this will be 9 times 3, which is negative 27 x squared. So our limit is what x goes to what 1, so we have to substitute. So we can say 20 by 1 power 4 minus what h by 1 all over what minus 1 minus 27 x 1 square. So we have what 20 minus h all over what minus 1 minus 27. So we'll end with what 20 minus 7 is 20, what is 20 is 12 all over what minus what 28. So we have what negative 3 by what 7. So this the last question is given as to what to find the limit as what x goes to 0 of what 2 sine what x minus sine 2x all over what x minus what sine x. So using hospital rules, using hospital rules. So using hospital rule, we can find derivatives of derivatives of you can see you have 2 cos x, yes, minus here is since x has coefficient we can shift back, we have minus 2 cos 2x. Then derivatives of this x is just 1 minus what here is derivative of sine is cos, so we have cos x. If you say since we have limit at x goes to 0, if we say here to be equal to 0, then we have what here is what 1, then here is what 0, then 2 minus 2 is what 0, and then for the numerator we have 1 here, and then if we substitute x to be equal to 0 here, we will have what 1, then which is 0. So we are to what to do the hospital rule again. So to do hospital rule, we are the same procedure. We are to use the same procedure. I have to just take derivative of this and also derivatives of this. So to find the derivatives of this, you can say here is minus what 2. If then cos derivative of course is minus sine, so we have minus 2 sine what x, and then derivative of this cos is minus sine, we have minus here, so we have minus this coefficient is 2 times 2 is 4, so we have what plus 4 sine 2x all over derivative of this constant is what a 0, so we have minus also derivative of cos is what minus sine, so here we'll end with what cos sorry sine x. So to do so, we also have limit as x equal to what 0. So we know we can't use 0 sine 0, so we have to differentiate again. So we have to use hospital rule again so that it become cos. If it become cos, you know cos of 0 is going to be equal to 1, so we have to differentiate again so that we will have definite value. So to differentiate this, here we get f prime, here is what f prime, here we have f prime. So we do hospital rule 3 times. So the next thing is to differentiate this and this. So differential of this sine we know is what cos, so we can see minus what 2 cos what x, and then here is just to differentiate this 2 times 4 is plus h cos what 2x, and then sine is just cos, derivative of sine is cos what x. So our limit is what x goes to what 0, so we have to substitute. So if we put 0, we can say minus what 2 cos 0 plus h cos what 2 times 0 is 0 all over what cos what 0. So cos 0 as we know is 1, so we have minus 2 negative 2 plus what h all over what 1, negative 4 plus h is just 6 by 1, which is what 6. So the answer is going to be equal to 6. So this is the final solution. Don't forget to subscribe, give a like and comment. Thank you for watching. See you in the next video.